Did you know that reality itself might not be what it seems? At the quantum level, particles exist in multiple places at once, defying everything we know about physics. This isn't science fiction. It's proven science that challenges our very understanding of existence. Scientists have conducted experiments that show particles literally behave differently when observed versus when they're alone. It's as if the universe knows when we're watching and changes its behavior accordingly. This quantum weirdness forms the foundation of our modern world, from the computer chips in your phone to the mysteries of black holes. But what if I told you there's an even deeper secret hiding within this quantum realm? The story begins in the 1920s, when physicists first stumbled upon quantum mechanics. They discovered that electrons and other subatomic particles don't follow the same rules as larger objects. Instead of having definite positions, they exist as probability clouds, mathematical descriptions of where they might be. This was so bizarre that even Einstein famously said, "God does not play dice with the universe." But the evidence kept mounting. Double-slit experiments showed that particles could behave as both waves and particles simultaneously. When not observed, they spread out like waves, but the moment scientists tried to measure them, they collapsed into definite particles. This observation effect suggests that consciousness itself might play a role in shaping reality. Then came the discovery of quantum entanglement, what Einstein called spooky action at a distance. When two particles become entangled, they remain connected no matter how far apart they are separated. Change one particle, and its partner instantly changes too, faster than light could travel between them. This violates our understanding of causality and suggests that space itself might be an illusion. Recent experiments have confirmed entanglement over distances of hundreds of miles. Scientists have even teleported quantum information using entangled particles. This isn't theoretical anymore. Quantum networks are being built right now that could revolutionize communication and computing. But the implications go far beyond technology. They challenge our very concept of separate existence. The most mind-bending interpretation of quantum mechanics is the many worlds theory. This suggests that every quantum possibility actually happens, but in different parallel universes. When you make a decision, even something as simple as choosing coffee or tea, the universe splits into multiple versions where each choice occurs. Your consciousness follows one path, but countless other versions of you experience the alternatives. This isn't just philosophical speculation. It's a mathematically consistent interpretation that solves many quantum paradoxes. Some physicists believe we're living in just one of infinite parallel realities right now. Every moment, new universes branch off from ours, creating an ever-expanding multiverse where all possibilities exist simultaneously. The implications are staggering. Every choice matters infinitely. But here's where it gets truly bizarre: the role of consciousness in quantum mechanics. The Copenhagen interpretation suggests that quantum systems only become definite when observed by a conscious being. Without observation, reality remains in a fuzzy, probabilistic state. Some physicists argue that consciousness isn't just observing reality, it's creating it. This idea, while controversial, has gained traction among leading quantum theorists. Experiments with delayed choice quantum erasers suggest that observations can affect events that already happened in the past. It's as if the universe is retroactively determining what occurred based on present observations. This time-symmetric view of quantum mechanics suggests that cause and effect might work both forward and backward in time, fundamentally challenging our linear understanding of reality. The practical applications of quantum weirdness are already here. Quantum computers leverage superposition and entanglement to perform calculations that would take classical computers billions of years. Google's quantum computer solved a problem in 200 seconds that would take the world's fastest supercomputer 10,000 years. Quantum cryptography uses the uncertainty principle to create unbreakable encryption. Any attempt to eavesdrop changes the quantum state, alerting the users. Quantum sensors can detect gravitational waves and magnetic fields with unprecedented precision. But the most exciting development is quantum biology. Evidence suggests that photosynthesis, bird navigation, and even our sense of smell might rely on quantum effects. Life itself may have evolved to harness quantum mechanics, suggesting that quantum weirdness isn't just physics, it's biology too. The quantum revolution is accelerating faster than anyone predicted. Quantum internet prototypes are already operating, using entangled photons to create unhackable communication networks. China launched the MISHIS satellite specifically for quantum communication experiments, achieving entanglement over 1,200 kilometers. Companies are developing quantum sensors that can detect underground resources, monitor brain activity, and even predict earthquakes. Quantum imaging allows seeing around corners and through obstacles by measuring quantum light patterns. But the most profound development is quantum artificial intelligence, machines that think using quantum superposition. These AI systems could solve problems incomprehensible to classical computers, from designing new medicines to optimizing global economies. We're standing at the threshold of a technological revolution that will make the digital age look primitive by comparison. The most controversial and exciting frontier is quantum consciousness theory. Some neuroscientists and physicists propose that quantum processes in microtubules within brain cells could explain consciousness. This theory, while hotly debated, suggests that our thoughts, memories, and sense of self might emerge from quantum computations happening at the nanoscale. Experiments have found evidence of quantum vibrations in microtubules, and some anesthetics work by suppressing these quantum oscillations. If true, this would mean consciousness isn't just a classical computational process. It's fundamentally quantum. Your free will, creativity, and even your subjective experience of reality might depend on quantum coherence in your brain. This would bridge the gap between quantum physics and consciousness, solving the hard problem of how physical processes create subjective experience. Within our lifetime, quantum technology will transform everyday life. Quantum computers will design personalized medicines based on your genetic quantum state. Quantum sensors in your phone will detect health issues before symptoms appear. Quantum encryption will protect your digital identity completely. Quantum navigation will work anywhere without GPS. But the most profound change will be in how we understand ourselves and our place in the universe. The quantum revolution isn't just about better technology. It's about a fundamental shift in our conception of reality. We're discovering that the universe is far stranger, more interconnected, and more mysterious than we ever imagined. The boundaries between observer and observed, between mind and matter, between possibility and actuality are blurring in ways that will redefine human existence. The implications extend to the cosmic scale. Quantum fluctuations in the early universe seeded all structure, galaxies, stars, planets, and ultimately us. Without quantum randomness, the universe would be featureless and lifeless. Some cosmologists suggest that the universe itself might be conscious, a vast quantum system aware of itself through us. The anthropic principle notes that the fundamental constants of physics are perfectly tuned for life, suggesting either incredible luck or something deeper. Quantum cosmology attempts to understand the origin of the universe from a quantum perspective, proposing that the Big Bang emerged from quantum fluctuations in a pre-existing vacuum. We might be living in one universe among countless others in a quantum multiverse, each with different physical laws and possibilities. What does all this mean for you right now? It means that reality is far more participatory than we thought. Your observations, attention, and consciousness might actually influence the quantum substrate of reality. The choices you make might create branching parallel universes where different versions of you experience alternative outcomes. Your very thoughts could be quantum processes interacting with the fundamental fabric of existence. This isn't to say you can manifest anything through thought alone. Quantum mechanics operates within strict mathematical rules. But it does suggest that consciousness and reality are deeply intertwined in ways we're only beginning to understand. The quantum revolution is revealing that we're not separate observers in a predetermined universe. We're active participants in creating reality moment by moment. The ultimate quantum secret is this: reality is not fixed and objective, it's relational and participatory. At the most fundamental level, the universe responds to how we interact with it. Quantum mechanics shows us that the observer and the observed cannot be separated. They form a unified whole. This means that your consciousness isn't just inside your head looking out at reality. It's part of reality itself, co-creating the world you experience. The quantum revolution is transforming our understanding from a universe of separate objects to a universe of interconnected relationships. Your choices matter in ways deeper than you imagined, and your consciousness plays a role in the cosmic dance of reality. Subscribe for more mind-blowing facts about our quantum universe. The truth is stranger than fiction, and we're just beginning to uncover its deepest mysteries. Subscribe for more mind-blowing facts. Fire.